Hey, welcome back to Nebraska Canoe, or I should say, if you haven't been here, welcome to Nebraska Canoe. My name is Jeff. This video is really a follow-up to a previous video that I made called Basic Geometry of a Canoe's Hull. And what you see on screen are the three curves that I talk about in that video. And this is really why I was exploring those curves, trying to boil down the geometry of a canoe so that I could then turn around and apply it in this manner. So in this video, you can see I've got a bit of kind of a basic canoe hull on screen, and I'll tell you why that's a little bit unique here in a minute. But what we're going to do is we're going to go through an exercise where we're going to create or design a hull, and I think we're going to pursue a design that's pretty much like a prospector canoe. I think that'll just let us see what's happening here. So the 3D modeler that this is being done in is Rhinoceros 3D. And in the background, the part that you can't see, at least not see most of, is called Grasshopper. And it's a graphic parametric modeler. So it is taking parameters that we feed it from the computer, and it's creating the model for us. So it knows where our start point is and a bunch of other information, and it builds this in real time. So on the right side of the screen, you can see where it says Grasshopper, and there's a series of toggles and drop-down menus that have been created inside of Grasshopper that's creating the model that we see before us. And you'll see what I mean, or how things move, here in a minute. So let's just start off with the transverse section of geometry. I'll go ahead and turn on that geometry with my toggle. And if you've seen the previous video, this should start to look familiar. What's cool about parametric modeling is as we adjust it, it's going to adjust it on the fly. So since we're starting with the transverse section geometry, I'm gonna drop down the transverse section, and it gives me a series of sliders. So our beam in inches is right now at 29 inches. You can see as I adjust that beam dimension that it's changing our model in real time. So since we're looking at like a 16-foot prospector, let's bump it up to, I believe mine has a 35-inch beam. It's just shy of 36 inches. And then the depth is right now at 11. Mine is actually a fairly deep model. It's at 14 inches. So let's do a center depth or a depth at the beam of 14 inches. And then the chine radius, that's the radius that blends the side of the boat to the bottom of the boat. Right now it's at 10. Let's bump that up to, let's stick around 14. And I believe that 14 number is the diameter of the circles you're seeing on screen. So we're at about a 7-inch radius. The grid, I should say, on the bottom, the grid on screen is a 12-inch grid. So you're seeing 1-foot lines in the darker lines. And that just helps us kind of get a feel for the dimensions that we're seeing. Lastly, well, not lastly, but second to last, we've got the roll radius. So we can adjust that to where we have a lot of roll in the bottom of the boat. Let's soften it, but we won't soften it too much. We'll put it about right there. That's actually a 48-inch radius. So that's a decent, seems like a decent amount. And then the sides of the boat, we can either flare those out or give them what's called tumble home. So as I adjust, you'll see what I mean. We can flare the sides of the boat out in section, or we can draw them in and give it some tumble home. We're going to give it a little bit of tumble home, not too much, but a little bit to keep it as narrow as possible at the gunwales. And that basically completes our transverse section. So let's shut the transverse section geometry off. We can still see the main primary curves. And then we're going to minimize our drop-down menu. Next, we're going to move to the longitudinal section geometry, which I'll turn on. And then we'll switch our pull down for the longitudinal section. I'm going to actually change our grid so that our grid is now running vertically along the center of our boat. And that just allows us to read the geometry that we're working on against that grid. So the length, we were at 14 feet. We were going to go to 16. Yeah, so my grid is right at 16 feet. Let's just leave it there. That's just fine for now. The rocker radius, so since we're in the long direction, believe it or not, this is a radius. It's just extremely long. But as we shrink that down, you'll see the bottom of the hull start to bend up and give us lots of rocker. Okay, so let's zoom in here to the nose of the boat. Right now we got about 4 inches of rise. That's too much. We want more like 2 inches. Let's adjust that down. Yeah, right there. That's pretty close. Got about 2 inches of rocker. It's maybe a little bit much, but let's just keep it there. And then lastly, the stems at each end, we can either, similar to the transverse section and the sides, we can either flare our stems out or draw them back. So if we adjust that, we can put some flare on the nose, but most prospectors, they're going to be drawn back. So let's draw them back. And I actually skipped one. I skipped the stem radius, and I think it's kind of nice to be able to see what's happening on the stem before that radius gets too big. Otherwise, it becomes hard to see. So we're going to draw those stems back. Like that, we'll start there. We can always adjust it in the future. And then the stem radius, we're going to bump that up because the prospector has a fairly soft radius on the stems. Let's match what we did at the chines. And we'll just go at a 7-inch radius. I think that feels pretty good. And that completes our longitudinal section. So we're going to leave the vertical plane on here for a sec as we move on. So I'm going to minimize my longitudinal section. I'll shut off that geometry, and we're going to move on to the gunwales, which is the blue line. You can see how right now the blue line, the top of the boat is perfectly flat, meaning it has no shear. It's just sliced evenly at a singular height. We're going to turn on our gunwale geometry, and you'll see that there's actually 2 curves because the gunwales are a 3-dimensional curve. Right now, they're 2-dimensional. We're only bending it in one direction. I'm going to turn my gunwale curve sliders on over here, and we're going to add some shear. So shear adds height to the boat from the top. So we're going to add, let's just add 5 inches. Actually, let's add a lot so you can see what's happening. That's 18 inches. So it's added 18 inches of height. And now you can see these 2 green curves. These 2 green curves are actually what's creating the blue curve. The blue curve is a blend of both of them. You can see one curve is an image of the blue in elevation, and the other curve is the image of the blue in the plan view. So it's those 2 curves that we're working with now. In the shear, we're just moving this center curve. So that's obviously too much. Let's drop that back down to something more reasonable. Let's just say 5 or 6 inches. 6 inches seems pretty heavy, but let's go with that. Let's just go with that. And then you'll notice kind of the sweep of this. We can also adjust that using this point that you see here in the middle. So I can move this slider, and that will adjust where that point is. Think of that point like a magnet, and it's affecting how that curve, how gentle or tight that curve is. We can tighten it up very tight towards the bow and the stern, or we can ease it up. And we're gonna put it somewhere about like this. And our main goal here is just to keep the gunwales low at the paddling station. So about where the paddling station is, we're going to place that point just about there to try to keep a little bit of that height focused towards the end of the boat and not so much in the middle. Now we're going to adjust the curve that is in the plan view. So this green curve here that's also changing our gunwale, we're going to look at that from the top. So I'm going to change the grid to the top. Let's just look at the boat from above. So now we're going to adjust the fullness. Here, as I adjust, you can see what I mean. It's very similar. We're just moving this point, and it's changing how this curve, how tight or gentle this curve is. So if we reduce its fullness kind of to something like this, we have something that looks more Winona-esque. We've got a very narrow entry and exit, great for flat water. And then we can move it out and the boat becomes much more full, something that's more akin to whitewater where you want to bob on the surface. So the Prospector is very much a do everything kind of boat. It lands somewhere in the middle. So let's just find a gentle medium with a decent amount of volume that you could load it up with gear and trip in it comfortably. We'll go about right there. So that completes basically our adjustments of the transverse, longitudinal, and the gunwale curves. So I will toggle off the gunwale geometry. And in order to keep the computer running, I haven't had a surface turned on, but we're going to go ahead and do that now so we can start to see what it is that we are creating. So under calculations, I'm just going to turn on what's called the network surface. And we're going to toggle on our surface. Now, the computer is thinking a little bit harder because not only is it creating the surface off of the curves that we just made, but it's also extracting information from it. Even though we can't see it on screen, it's already making that information for us. And I simply have it turned off so we don't see it. But let's start to take a look at that. Let's turn on the water line. So this is a 4-inch water line. I believe I've got a setting here. Yeah. So right now this water line is at 4 inches. I can go ahead and turn on a surface to give you kind of an idea of what I'm talking about. This is where when the boat is sitting in the water, this is the boat at a depth of 4 inches. It's kind of a typical design depth for a boat. It could run deeper, it could run shallower, but this is kind of the design depth. Right now it's at 4. We could adjust it up. You can see it moving on screen. If I push it way up, that is a 10-inch water line. So that is the boat loaded up very, very heavily. You wouldn't want to paddle that with such a small amount of freeboard. But we can nonetheless understand information about it with the parametric model. So we're going to back that back down to 4 inches. 3, 4. There we go. And I'm going to shut the waterline surface off. I'll go ahead and shut the waterline off too for now. Next, I would like to turn on the line work. So the line work, since the computer has created the surface, it can also cut sections to that surface. And now we can begin to understand the stations of the boat. If you've designed a boat or read a book about designing a boat, you'll know that stations are simply locations of sections cut through the hull to help you understand what its shape is at those given points, and then you can build to those lines. So I can adjust the station density. Right now, I believe this number is a bit arbitrary, so the number is less important than as I move the slider, it will make the stations denser. Or in the other direction, it will make them less. There's basically, 3 stations there, and so on. So let's just put it to a reasonable number because, like I said, the computer is thinking about all of this and holding on to it, and so it does slow things down. But what's cool about that is you can go direct from this design and again, what you don't see in the background is if I turn on the station surfaces, it's creating, based off of those sections, station plates. So these are something that you could output to something physical, put onto plywood and a strong back in the garage, and begin to create this hull in real life. So all kinds of information like that can be pulled out in real time. So that is the station surfaces. And you can see as I increase the density, how it's creating those at the same time, all of those station surfaces. Okay, so let's shut the station surfaces off And we'll go ahead and shut the line work off, and we'll back our, actually, let's just back our station density back down to something more reasonable. Okay, and since this is parametric, now we have a surface. We have a surface, we have, which means now the computer understands the area of that surface. It also understands the volume of that surface. So I will turn the water line back on, I'll turn the line work off, and now we can begin to look at some information about the hull itself to kind of understand what we're getting. And this is just kind of a brief taste of what you can do. So we're going to turn on some text, and this text is real time. It's giving us data about what we're actually seeing on screen. We've got a 16-foot length overall, got a 35-inch beam overall, a 14-inch center depth, and a 1.8-inch rocker. Our weight in carbon fiber is plus or minus 43 pounds. We'll come back to that here in a sec. The capacity at a 4-inch water line is 353 pounds, give or take. Of course, that's just an estimate. Our length at the water line is 15.7 feet, and our beam at the water line is 32.3 inches. You'll note that the beam and the length at the water line are smaller, and if we look at the boat in a top view, you can see how the overall dimensions of the boat are larger than what the boat's shape is at the water line. You can even see how the curvature is different at the water line, which is this blue line, than it is at the overall extents of the hull itself. Coming back to the weight in carbon fiber, what I did basically was I gathered some data online, different companies, mostly I think I operated off of Nova Crafts materials, and created a general weight to surface area number that's based off of some real models that are on the market, and that just helps me understand generally where things would start to fall in. So I do have a material toggle here. Right now, that's the weight in carbon fiber at plus or minus 43 pounds. If I move that toggle, you can see it changed to weight in air mid-light. Kevlar, plus or minus 40 pounds. Once again, Tough Stuff Expedition, plus or minus 56 pounds. Tough Stuff, plus or minus 50 pounds, and so on and so forth. Fiberglass, plus or minus 50 pounds, 59 pounds. So I think we'll stop there. There's a lot to explore, a lot to understand. I guess one more thing. In terms of capacity, right now our capacity at a 4-inch water line is plus or minus 353 pounds, right? So that would fit two kind of smaller paddlers. But let's say, okay, we have a 14-inch center depth. We want to have a minimum of 6-inch freeboard. Let's say that's how much of the boat we want out of the water to feel like we can paddle it safely. So 6 inches off of 14, that's 8. So at an 8-inch water line, we move the water line up to 8. You can see how our numbers have changed. So now our capacity at an 8-inch water line is calculated at 930 pounds. So we could load this boat up to 930 pounds. It would paddle pretty rough, but you can see it hasn't risen up above the chine curve. But that gives us yet a 6-inch freeboard. So we can just kind of know information like that and pull it directly from the model. I hope you found that interesting. If you have any questions or comments, do leave them below. Thanks for watching. If you haven't seen the previous video, Basic Geometry of a Canoe Hull, I encourage you, go back to that and watch that, and you'll sort of see an explanation of the curves that you see here in this video. Until next time, take care. Thanks.